Right, use a calculator to find the missing side length and then tell whether the side lengths form a Pythagorean triple or not. So here's our missing side. It happens to be the hypotenuse. Let's use the Pythagorean theorem here. A squared plus b squared equals c squared. We substitute our legs are 8 and 6, and our hypotenuse we don't know. That's our x value we're trying to find. Do our squaring. 8 squared is 64. 6 squared is 36 equals x squared. We add 64 and 36 gives us 100. And our last step to get x by itself is to get rid of that squared. We take the square root of both sides. And the square root of 100 is 10. So our missing side is 10. The second part of the question was tell whether the side lengths form a Pythagorean triple. We have side lengths 6, 8, and 10, and the answer is yes. The reason for that is a Pythagorean triple has two things. They have to satisfy the Pythagorean theorem, which they did, okay? And they have to all be whole numbers, which they are. Okay, same type of problem. We start with our Pythagorean theorem. Put in the numbers that we know. Well, we have one leg that's 10. The other leg we don't know, so we're just going to leave it as b. And the hypotenuse is 11.8. Let's do our squaring. 10 squared is 100 plus b squared equals 11.8 squared is 139.24. Subtract 100 from both sides. That gives us b squared is 39.24. To get rid of the squared, we're going to take the square root of both sides. What we get b is about 6.3. Okay, so our missing side is length 6.3. We have to answer the other part of the question too, which was, do the side lengths form a Pythagorean triple? Do the side lengths 6.3, 11.8, and 10 form a Pythagorean triple? And the answer is no. They do form a right triangle. However, we have two numbers that are not whole numbers, so it cannot be a Pythagorean triple.